This is from Bellingham Technical College Tutoring. We're going to go over Chapter 3, Probability Topics. There is a worksheet that is also associated with this video, and you can get it on the website. This chapter in particular is about probability, which is the chance a future event occurs based on previous experience. There are two types of probabilities. One is the observed probability from experiments or surveys, typically known as relative frequency, or two, the theoretical probability based on a mathematical model. Our learning objectives in this chapter is that students should learn the following topics from the chapter in the book. Review and understand the terms in probability. Know the difference between mutually exclusive and independent events. Know when and how to use addition property and the multiplication property, and be able to construct and interpret a two-way contingency table. So now we're going to look at the key terms in this chapter. The first key term is experiment. This is the process of repeated operations under controlled conditions, such as the tossing of a fair coin 3 times. A random experiment is one where the chance of an outcome occurring is not predetermined. Outcome: an occurrence or an individual result of an experiment. For example, in the tossing of a fair coin, there are two possible outcomes, heads or tails. Sample space: that is the set of all possible outcomes of an experiment or survey. Event: a combination of outcomes, like, for example, the event of choosing a red card in a 52 deck of cards. Observed probability: the long-term relative frequency of an outcome. And we want to recall that the probability of any event has to be between 0 or to 1, and it can be 0 and it can be 1. Theoretical probability: that is the number of ways an outcome can occur in a sample space based on equally likely events. Equally likely: the probability of choosing an outcome is the same for all possible outcomes in the sample space. The term independent events: that is, the occurrence of event A has no effect on the probability of the occurrence of event B. And likewise, event B has no effect on the probability of event A. Mutually exclusive events: the outcome of event A are not included in the outcomes of event B. And finally, the idea of a complement of an event: outcomes that are not in event A. The outcomes in event A and in event A complement together make up the sample space. That is, the probability of A plus the probability of A complement equals 1. So now in this chapter we're going to look at the laws, rules, and properties of probability. So we're going to look at key rules and laws. For example, the law of large numbers: as the number of repetitions of an experiment is increased, the relative frequency obtained in the experiment, that is, the observed probability, tends to become closer and closer to the theoretical probability. The first rule of probability is that each event in the sample space has a probability value between 0 and 1 and can equal 0 or 1. So 0 is less than or equal to the probability of event E, which is less than or equal to 1. The second rule of probability is that the sum of the probabilities of the event in the sample space equals 1. That is, the sum of all the probabilities of all the events in the experiment has to equal 1. Now we're going to look at some probability equations. The relative frequency calculation. If x is a countable number of outcomes for event A, and n is the total number of possible frequencies for all outcomes in the experiment, then the probability of A is equal to x, the number of outcomes in A, divided by the total number of outcomes n. The addition property. For any two events, A and B, we have the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Mutually exclusive property. If A and B are events that are mutually exclusive, then the probability of A and B is 0. And we just have the probability of A or B to be just the probability of A plus the probability of B. We're continuing on with properties of probability. And in particular, we're going to talk about the multiplication property. For any two events A and B, the probability of A and B occurring for independent events, which means that the probability of A and B are not affected by each other, the probability of A and B is equal to the probability of A times the probability of B. Dependent events for probability of A and B is that the probability of A times the probability of B given that A has occurred. And finally, if we multiply both sides of the equation by the probability of A, we get the conditional probability of probability A given B, or in this case, the probability of B given A. So the probability of B given A is equal to the probability of A and B divided by the probability of A. Likewise, if we had the probability of A given B, that's just equal to the probability of A and B divided by the probability of B. Some simple examples. Under independence. Suppose a person draws one card randomly from a 52 deck of cards. What is the probability of the card being a king and a red card? So now we have the probability of a king is just 4 out of 52. And we also have the probability of a red card being 26 out of 52. Thus, under independence, the probability of A and B is equal to 4 divided by 52 times 26 divided by 52, which ends up giving us 1 over 26, or approximately 3.846%. Now let's look at how to calculate it under dependent situations. Suppose a person draws one card randomly from a 52 deck of cards. What is the probability of a card being a king given that it is red? Well, in this case, given the idea we have chosen a red card, how many kings are there for red cards? Well, there's 2 out of 26. So the probability of a king given a red card is 2 out of 26. the probability of red is still the same. It's still 26 over 52. And so now the probability of a king and red card is 2 divided by 52, which is the probability of red, times 2 divided by 26, which is the probability of king given red, which gives us 2 divided by 52, which, guess what? It's the same number, right? 3.846%. So now we're going to do some problems in Chapter 3. These are some problems that are out of the book. The first problem is let the probability of a student takes a math class, the probability of G is equal to 0.5, and the probability a student takes a science class, probability of H, equals 0.6. Also, the probability a student takes both a science class and a math class is the probability of G and H equals 0.3. Find the following probabilities. Well, we want to find the probabilities of G or H. We want to find the probability of G given H. And then, are the probabilities independent? What we mean is, are the probabilities G and H independent? So for the first particular solution, the probability of G or H, we're going to recall we have the following equation. The probability of G or H is equal to the probability of G plus the probability H minus the probability of G and H. So here's our solution. The probability of G or H is equal to 0.05. That's for math. Probability of 0.6 is for science. And then for students taking both is 0.03, and we get 0.8. So thus 80% of the students at the school are either taking a science class or a math class or both. In our next case, we want to find the probability of G given H, and here is our equation for that. The probability of G given H is the probability of G and H divided by the probability of H. Here the probability of G and H is 0.3, and the probability of H is 60% or 0.6. So when we divide those, we get 1/2. And now we have the probability of G given H is 50%. Now we're asked if in fact we have independence, and this is written incorrectly. If the probability of G given H equals G, not H, then we have independence. And yes, events G and H are independent because the probability of G of H is equal to 0.05 and the probability of G is 0.5. So we have independence. Now we have Chapter 3, a second problem. A community of swimmers. Let's see, we have a swim team that has 150 members. 75 of the team members are advanced and 40 of them practice 4 times a week. 47 are intermediate swimmers and 30 of them practice 4 times a week. 10 of the novice swimmers practice 4 times a week. Suppose one of the members of the swim team is randomly chosen. A. What is the probability that the team member is a novice swimmer? So we're going to look at that one first, right? So the number of novice team members is equal to the total minus what was left over for the advanced and the intermediate. So that's what we subtract. We subtract 75 and 47 from 150 and we get 28. And now the probability that we have a novice swimmer, if we randomly choose a swimmer, is 28 divided by 150, which ends up being 0.1867, or about 18.67%. The second question, B, what is the probability that the member practices 4 times a week? Well, the number of team members practicing 4 times a week, well, we know for the advanced there's 40 that practice. For the intermediate there's 30, and we were told that 10 novice practice 4 times a week. That gives us 80, and so the probability that we choose a swimmer that practices 4 times a week is 80 divided by 150, or 8 divided by 15, which is 53.33%. Finally, we're asked what is the probability the swimmer is advanced and practices 4 times a week? Well, there's our statement, the probability advanced and practice 4 times a week, which is, we know there's 40 that practice 4 times a week out of 150, right, which is 4 divided by 15, which is 26.67%. Our final problem in Chapter 3 that we're going to look at is called a contingency table. Here, a contingency table has 2 variables. In this particular case, our category of speeding violation or no violation is 1 variable. The other variable is you're either using a car phone or not using a phone in your car. So, suppose a study of speeding violations and drivers who use a car phones produce the following fictional data. Here they are. And each of the numbers represents not 2 different categories. One is either a speeding violation or a non-speeding violation, or a car phone use or not a car phone use. So the first question is, what is the probability of a speeding violation? So our solution is the probability of a speeding violation is equal to 70 divided by the total, which in this case is 755. So it looks like about 9.27% of the folks in this study have a speeding violation, regardless of whether they're using a car phone or not. Now the second question is, what's the probability of a car phone user? Well, I'd like you to pause the video and try to calculate what that currently is, and then we'll come back and show you how to do that. So go ahead and pause, and we'll wait for you. So hopefully you have the answer. But if we want to know how many use a car phone, we just go to the column where the total is 305. So the solution of phone, say, is equal to 305 divided by the total, 755, right? That's how we would calculate it. The third question is, what's the probability of a speeding violation given, there's that word given, a car phone user? So we write it this way, speeding given a phone user. What we do is we go across the row of our given that we have a phone user, right? And we look at how many of those were speeding violations. We have 25. So we end up with 25 divided by 305. The given tells us to separate the population based on the given in the problem. So that's why we separated out car users from non-car users, or phone users in this case. The final question is, what's the probability of not a phone user and speeding? There's a term, and. Now we're looking at the intersection of a not a phone user and speeding to the total. Okay? So again, I'd like you to pause the video and see if you can come up with the solution. Good. You were able to do this. Now, let's see how it is. So the probability of not phone and speeding, right, is equal to 45 divided by 755, right? So there's our intersection, right? Our intersection is this number here, where speeding violation and not a car user come together, divided by the total. Well, that concludes our Chapter 3 review. Please go through the book and work some additional problems, and go through the worksheet.